All right, here we go. So as I said, bell work's really important today. We are talking, this is basically going to lead into our lesson. So bell work is basically, we're starting the lesson. Okay. Some of this stuff you can do without me. That's why I put it as a bell work question instead of me just teaching you how to do it. It's just a little bit of using what you know and solving. Okay. So we're solving each logarithmic and exponential equation below. Log base 3 of 3x minus 1 is equal to 2. If I wanted to solve that thing, Aaron Cardinal, what would I do first?
I just turned it into 3 squared equals 3x minus 1.
Great. We get rid of the log base 3 by taking it as 3 to a power. Good. Okay. And however you say that is perfectly fine as long as you get 3 squared is equal to 3x minus 1. Great. Once she's done that, 3 squared, oh yeah, that's 9. We add 1, and we divide by 3. All right. Again, this is the exact answer. Not going to your calculator is an exact answer. If they asked you for the approximate answer, you would take 10 divided by 3 and get 3.333. Okay, that would be your approximate answer. That's the exact. Let's look at number 2. Log base 5 of 2x plus 3 is equal to log base 5 of 3. Anybody got an answer on that one? Yep, what'd you do, Megan? Sure, we could give both sides a base of 5, and if we gave the left side a base of 5, that would cancel. It would leave you with 2x plus 3. And if I gave the right side a base of 5, that would cancel, and it gives me just a 3. Perfectly fine. You really don't even have to think base of 5. As long as you just see, hey, both sides are just log base 5, those things are going to cancel. It's like saying both sides are 5 to a power. They're going to cancel because they're the same base. Great. Then we solve 2x equals 0, x equals 0. Number 3, 5 to the negative x. Megan. 25 into 5 squared, so she's rewriting the bases. Then we cancel the 5s. Negative x is equal to 2. X is negative 2. We've done that one all day. Great. 3 for 3. Let's get a little bit tougher here. Number 4 says 3 to some power equals 14. I'm trying to get x by itself. What do I need to do here to get x by itself? Max? Log base 3 both sides. So we're taking the log base 3 of 3 to the x is equal to the log base 3 of 14. And we talked about this yesterday a little bit. You don't even have to use log base 3. You could have just used log and gotten rid of it that way. It would have been a little bit uglier, but just do it this way. It makes sense. Okay? So what that means here is log base 3 and 3. Those two things are just going to cancel. And over there, I just got to do the log base 3 of 14. This is the exact answer. Okay? This is exact because I've got all the numbers. I didn't have to round it. I didn't have to type into my calculator. That would be exact. If I were asking you for the approximate answer, then you got to type it into your calculator and get 3 decimals. Okay, so remember we did this all day yesterday. To do that, you could do log of the number divided by log of the base. You could type it in like that. That's easy to do. Or if you want to use log base, you go alpha F2 down to number 5, log base 3 of 14. Hit enter, boom, same thing, 2.02. That's the exact, or I'm sorry, that's the approximate answer because I used my calculator and rounded my answer in the end. Questions there? Number 5 is why we learned our lesson yesterday. 2 log base 3 of x plus 4 minus log base 3 of 9 is all equal to 2. Before we do anything else on 5, we got to recognize that we see multiple logs on the same side. If you see multiple logs on the same side, the easiest way to do this is to condense it. Okay? Before we do anything else, we are going to condense this thing. So we're going to make this, say, log base 3 just one time. Log base 3 just one time. So, Haley, what's that going to look like if I condense the left side?
I did log base 3, and then in the numerator I did x plus 1 plus 3 squared.
Good.
Over 9.
Over 9. Excellent. And that's all equal to 2. And so we condensed it first because now we've got a pretty straightforward question. Now I've got log on one side and not on the other. How do I get rid of log base 3? Base of 3. Base of 3. Boom, that's gone. Now I've got x plus 4 squared over 9 is all equal to 9. Now it's just a math problem. Now there's nothing new about this. This is not anything against what we've done back in Algebra 1 and Algebra 2. We're going to multiply by 9 on both sides. Then we are going to square root. What's the square root of 81 going to get me? I disagree. Yeah, it is 9 and negative 9. I always write it separate like that at this point. But we need to do that because we took the square root. We were solving x squared equals something. We took the square root. That's when it's plus or minus. And then to finish this thing, I'm going to subtract 4. So x is equal to 5 and negative 13. The answer is not 5 and negative 13. Sophia?
Why wouldn't you just see like log base 39 is 2, so you just like make that 2?
Log base 3 of 9 is...
Yeah, like in the original problem, that's just 2. So like, here you just like...
Sure. There are lots of ways of doing these problems. So Sophia's saying right here, she saw log base 3 of 9, and she knows that that answer is 2, and so she made it equal to 4 when you added it over. Yeah. Did you get the same answer? Yep, that's fine. And there's lots of different ways of doing it. Any way your mind works to get there, great. That's why I kind of like logs, because they make you think different ways. I'm doing it some way different. Yes, that works perfectly well. We condensed it first. Not always are we going to make it that simple at the beginning. But yes, that would work here. I was doing more of the idea of, hey, condensing. But yes, works. Okay? Both of those answers are not going to work. Negative 13 does not work. Why? Say again? Can't have a negative argument. Just because it's negative, bless you, doesn't mean it doesn't work. It's that when I plug negative 13 in right here, then I get a negative argument. If we would have solved this thing and gotten negative 3 for x, oh, that could work. Because if I plug negative 3 back in, my argument wouldn't be negative. But if you plug it back in and then your argument is negative, that is when it's not a solution to our problem. So it is just 5. Okay, let's get to this last one. 4 to the 2x is equal to 7 to the 1 minus x. This one's a little bit tougher. I want to get x by itself. How do I get rid of 4 to the power? Log base 4. And whatever I do to one side, I got to do to the other. And so it helps me on one side, but not really the other. In fact, let's make this easier on ourselves. Let's go log base 7, and I'll explain why. Instead of log base 4, let's do log base 7. And you'll see why here in a second. What's going to happen here on the right side, the log base 7 of 7? It's going to cancel. This, bye. That goes away. So on the right side, I'm left with just 1 minus x. That's why I decided to do log base 7 instead of log base 4. The right exponent was a little bit more complicated. And so now it's just 1 minus x by itself. It just made it a little bit easier. Now over here I got this. What can I do with this 2x? Properties of exponents, what we learned yesterday, we could throw that 2x in front. So it's 2x times log base 7 of 4. In general, what is log base 7 of 4? It's a number, right? It's just a number. Don't be scared by that. That's just a number. I can figure out what that is and highlight it right there if I just type it into my calculator. And if I just got numbers, then I can solve it. Okay? Finish that problem. Okay? See what you can do. Do not round it until you get to the very end. Don't round that answer until you get to the very end of it. See what you can do with that with your neighbor. Go. So in my calculator, I'm doing log base 7 of 4. So I'm going to go alpha F2, log base 7 of 4. And I'm taking that times my 2 because it was this times 2x. So I type that into my calculator. I hit enter. I get this number. Okay, I'm going to write down the rounded answer on my paper, but I'm not actually going to round it. I'm just writing it down so you can see it. Okay, so this is 1.424x equals 1 minus x. Or 1.245, whatever, doesn't matter. That's my problem. Again, I wrote down a decimal. I'm not actually rounding it, because if I round it, it's going to be off at the end. What do I need to do next to try to get x by itself? I'm going to add 1 to that. Add 1 to that, because now I'm going to get 2.425x is equal to 1. So I'm just going to say plus 1. Great, I get this. And then to solve, what else do I need to do? Divide. Divide. Again, I'm not rounding it. In my calculator, I'm taking 1 divided by, and then I'm going to hit the up arrow to pick the number I just got that's not rounded, and hit enter. I'm taking 1 divided by that whole thing, and I get 0.412. 0.412. Questions on something we did there? Like I said, okay, this is a big part of the notes for today. I'm only going to do like 5 examples with you today. This was the other 6. Okay, this is the other practice that we are trying to get without me having to hold your hand through all of them. You can do most of them on your own. I'm picking some tougher ones maybe to work with you. Questions there? All right, let's go to notes. All right, use a graphing utility to solve each equation. Express our answer as a rounded decimal. So looking at letter A, we don't want to solve letter A algebraically. Okay, and the main reason for that is I've got a log base 2 and a log base 6. I can't condense it. If I could condense it, I'd be all right, but I really can't. If I want to calculate this thing, I can do it in my calculator. Okay, you can solve any equation in your calculator if you know what you're doing. The best way to do that, this side right here, make that y1. And this side right here, make that y2. That's it. Okay. So earlier I had students say, well, can I just subtract 2 over and make it equal to 0? Sure. And then, can you move the log base 6 over? Sure. Whatever you want to do. Get one side of the equal sign, graph it. Take the other side of the equal sign and graph it. Let's try that right now. Okay. So I'm going to go to my y equals button. I graphed log base 2 of x minus 1, log base 6 of x plus 2, and I graphed 2. Do that real quick. Type that in. So we type that in. I'm going to hit zoom 6 just so my screen looks like yours. There's my 2 lines. I got a log graph, and I've got the line y equals 2, because that's what it's equal to. It's equal to 2. I'm trying to figure out where they cross. So if you just look at my screen right now, you can't really tell. So you might have to adjust your window. So I'm going to hit my window button, and I'm just going to be a smart math student. My x minimum, I'm going to make it 0 because it looked like everything I cared about was happening to the right. Make my x max, change that to like 20. Y min, it didn't look like I had to go down that far, so I'm going to go like -5. And a y max, I'm going to make it like 5. You don't have to do those same numbers. I'm just trying to move my picture. Okay? If we had a pinch to zoom screen, we wouldn't have to mess with this. But we've got an annoying calculator, so we actually have to change our window. Once I've done that, I'm going to hit graph again. And hopefully you can see that intersection spot. That's what we care about. We want to know when one side is equal to the other, so we want to figure that out. What am I going to do on my screen now in order to find that spot? Second, calculate. I am calculating the intersect number 5. I'm going to move my cursor to where I think they're on top of each other. I'm going to hit enter, hit enter, hit enter. Boom, there's my answer, 12.148. So nothing crazy about that. We're just graphing each one. Make sense on how to solve the graph? Or solve by graphing. Next one, we don't need to do it again. Okay, we could. E to the x, it looks like this. X cubed, it looks like that. You would find that spot. This is y1, this is y2. Find where they intersect. We could do that. I'm not going to worry about it. All right, let's go down below. So example 2. Solve each logarithmic and exponential equation. Write them as both exact and rounded 3 decimals. That's probably being extra. Okay, we can do that concept. We did it a little bit in bell work, but really more than anything, just know the difference between the two. What does exact look like? What does rounded to 3 decimals look like? That's what I want you to know. Okay, we'll get our answer how we get it, but make sure we understand that concept. Cool. Let's look at letter C. What do you think you need to do first on letter C? Condense it. Do it. Take a second on C. See what you can do with it. There is a way on C of making it a lot easier. See if you can find that a lot easier place. Here we go. So we're going to try to condense this thing. Lydia, or I'm sorry, not Lydia, I meant Aaron. Aaron, what do you think? Good. It's all equal to 3. So we condensed it first, and that made it better. Now I've got log 1 time. What else could I do at this point that would make this problem simpler? Megan? Yeah. So x squared minus 9, x plus 3, and x minus 3. She just factored that thing right there. And that's going to make this problem a lot easier because instead of having just a fraction in here, we can cancel the x minus 3's. Now I'm just left with this problem right here. And it just said, oh yeah, now we're a lot easier. Okay. So what Sophia's doing today a lot, she's saying, hey, why didn't we do this? Why couldn't we make it easier? And she's totally right. There's always a good way of doing that. Okay. If you can find it, great. We didn't have to cancel here at this point. We could have gone the long way and then factored it out at the end, but it would have been a lot harder on us. So finding that spot a little bit earlier is going to be easier to do. At this point, to get rid of log base 4, 4 to a power, 4 to a power. I don't know. Don't question me when I'm wrong. Sorry. I canceled the wrong one. X plus 3. Now we got 4 to the third. 4 to the third is going to get me 64. Add 3. X is 67. Condensing was the key. If we could simplify, we could simplify. Let's look at the next one. I'll do it kind of quickly here. We just did one very similar in Bellwork. E to the x plus 3 equals pi to the x. I'm trying to get x by itself. Right now, x is in both exponents. What can I do to try to make this easier? Let's do natural log. And again, I'm going to pick natural log because natural log and e are going to cancel. And this x plus 3 is a little bit more complicated of an exponent. And so I would rather it say, I'd rather this side over here just go away. I don't want to deal with you anymore. X plus 3 equals x times the natural log of pi. Again, we took this x, we brought it out in front. And so I can just do this in my calculator. The natural log of pi. The natural log. Natural log of pi. Gets me that number right there, 1.1447. What is it, 1.1447? So 1.145. Is there, what? Yeah, 5. X is equal to x plus 3. I'm going to subtract an x. So minus 1. And then I'm going to take 3 divided by that. 3 divided by that thing right there. You just got to be good with your calculator. I know I do that kind of quick, but it's just a matter of simplifying it down. I get 20.728. Yeah, see, that I was just thinking about that. Exact answer on this one, ugh, it would be rough. There's probably a great way of doing it, but why would you want to? Like, you're already dealing with natural log of pi and everything else. This would not be one that I would say, hey, you need to give me an exact answer. That's a great question. I had the same thought. So x is equal to 20.728. Questions there on D? Don't be scared by those. They look tougher than they are. Yep, subtract. Yeah. That was karma getting back at you for saying it happens. Try letter E. See what you can do on E without me. Or thoughts on letter E? What should I do first? Can I condense the left side right now? No. I've got a log and a number, and on the right side I just got a log. Well, remember that you can always manipulate an equation. If I add and move stuff, then the problem is going to become easier. So in this case, what do you think I should do? Put them on the same side. If you got more than one log and a number, put them on the same side. So we're going to subtract log base 3 of 4 over here. And then we are going to subtract the 2 over here. So basically I put the logs on the same side and the constant on the other side because that's going to allow me to condense now. By moving that over, now I can condense this without as many headaches. So log base 3 just one time. I get x plus 2 all over 4. Yes, ma'am.
Is the plus 2 is what keeps you from just taking a base of 3 on both sides?
Yes, because it would be 3. Yeah, because the 3 and the log base 3 would not cancel anymore. So great question. If I did this, then I would have to do 3 to a power to that whole side. And that's not going to cancel because of the plus 2 up there. Okay, we could write it as some different things, and you can do it that way because you could then say that this is 3 to the log base 3 of x plus 2 times 3 squared, and you can do some different things like that, but nobody wants to do that. It's way easier to manipulate when you move it over. Get rid of the log base 3, 3 to a power on both sides. So x plus 2 all over 4 is equal to 1/9. Multiply by 4. X plus 2 equals 4/9. Minus 2, so I'm minusing 18/9. So my answer is going to be negative 14/9. That's my exact answer. I could get an approximate answer by typing that into my calculator, but that is good for us here. So again, you could have not had to move the 2. It makes it way easier to move the 2. It just makes a lot more sense. Questions on E? All right, last one, letter F. And letter F, let's just throw a star by it. This is a great bonus question. Okay, this is a great bonus question, meaning that it's tough. Okay, if I do this here in a second and your brain melts down, don't worry. Okay, don't worry. Let's say I gave you this problem right here. Could you solve that? X squared minus x minus 12 equals 0. Can you solve that? All right, don't forget that here in a second. All right, so letter F. We look at this thing, and I've got 4 to a power and 2 to a power. That's kind of weird. Okay, the one thing we learned how to do was to change a base. Okay, so let's change 4 to a power as 2 squared. And I just changed it. I wrote them all to be a base of 2. And properties of exponents. What am I really doing with these two exponents? Multiplying them. So it's really the same thing as this. You agree with me on that? Which is the same thing as that. I just flipped them. It's the same. Okay? It's the same. It was 2 squared x. Now I flipped it to be the other one. It's a little weird. That is the trick to this problem. Okay? Again, here's what I did. It was 2 squared times x. I made it being multiplied. Oh, that's the same thing. I just moved them. And here's why. What does this look like? It is a quadratic. I have this thing. Don't see it as the number 2. See it as a thing. That thing is squared. This thing is to the first power, and that is a constant. It is the same thing as x squared minus x minus 12. Don't look at the 2. This is like, how many 2 to the x's do I have here? I have one of them. Okay, it's not like this times 3. If it were times 3, then it'd be 3x, but that's not what's written there. It's just one of them. It is like I took this problem right here, and everywhere I had an x, I substituted in 2 to the x. All right, it is a quadratic. So we have a quadratic. We can factor it. I need 2 numbers that multiply together to get me 12. Negative 12 in particular. and they need to add together to get me -1. -4 and 3. Then I'm going to set each one equal to 0 and solve. Go ahead and do that with your neighbor. Again, this is a challenge. If at first glance you look at it and you're like, that's extra. Yeah, it is. But do the best you can. You're smart people. We're setting it equal to 0 and we're solving. 2 to what power gets me 4? 2. X is equal to 2. 2 to what power gets me -3? That can't happen. Show me with your arm. What does 2 to the x look like? What does 2 to the x look like? When does it get negative? Never. It's at 0 or it's above 0. So this thing can't happen. My answer is just 2. Okay, and you could have plugged in 2 and figured out that that gave me 0, but that's the idea that we're trying to work with there. Questions?